Okay, I wanted to start doing some actual examples from Khan on this construct sinusoidal functions skill. And remember, I hope you've watched the template video that I put up because I'm going to use it. I'm going to show you how to use it on a specific example. So what we get here is not actually a graph, but details of the graph. We know that a sinusoidal function has a midline or has a point at the midline 0, -7, and then goes down to a minimum at pi over 4 and -9. Okay, so let me show you how we use the template for that. Okay, so I've started graph here because we recognize that we're starting on the graph end and that we're supposed to get the equation for it, right? We're supposed to get the formula for it, the sinusoidal function. So I start over here just to know I'm working my way from this side to this side, okay? And then I plot that first point, 0, -7. And I know I'm plotting it here because it's at the midline. And you see how I plot that the x coordinates down here and the y coordinates up here. Okay, so here's the point right here. Okay. Next thing I do is I plot the next point I'm given, right, which was pi over 4, -9. So the x coordinate pi over 4 is down here, and -9, the y coordinates down here, right across from it. Okay. Now what I'm going to do is I'm going to fill in the graph. Okay. And so I just draw, I know it's a sinusoidal curve. It's got this, standard sinusoidal curve. It's going down first, and then it must, if it goes anywhere else, it's not a sinusoidal curve. It has to go back up to its midline, up to the top, and then back to its midline to give you that kind of wave look of a sinusoidal curve. Okay. Next, I identify that the specific equation form I'm dealing with is negative sign. I don't know if you remember back to the template video, we talked about this diagram, and I'm starting inside the boxes and I want to figure out, well, I'm going down from a midline to a minimum, right? And then back up and back down. So I'm a sine and a sine function instead of a cosine function, and I'm negative. So we're going to use negative sign. And I've just filled this in right here. Okay. Now the next two things are the amplitude and the midline, right? I get the amplitude because there's two. There's between the midline and the minimum, there's a distance of 2. So that's my amplitude. Okay. That's easy enough. The midline's the easiest. We actually have a point on the midline, -7. So I'm just filling -7 in. Now, in my experience tutoring people, the next two are where people really struggle on the phase shift and the period. So I'll go a little slower with those. Now, we know, remember from the midline being here that our sinusoidal function, right, starts on a 0, right? So the phase shift actually is 0. That's where all sine, cosine functions start, is on 0 by default, right? And we will shift them left and right, as you'll see. But this one's doesn't have any phase shift at all. It just starts where sine and cosine normally start, at 0. Now, getting the period, what we want to think about, just like we thought about for the amplitude, we thought about the distance between the midline and the minimum, right, to get this amplitude of 2. Here we want to think, well, the sine, from the horizontal perspective, right, there's 4 different parts of the period, right? And I know going from 0 to pi divided by 4, right, is a distance of pi divided by 4. Pi divided by 4 minus 0 is pi divided by 4. So, and each of these parts are equal length. So I'm just adding up pi divided by 4 times. Another way to think about that is multiplying it by 4. So we get a period of pi, right? It could be 4 pi over 4 or just pi. Now what I do is I want to, I've got all this stuff filled in here. Once I have all this stuff filled in, I'm ready to go over to the equation. And I'm going to do the easy stuff first. Oh, I see my thing is cut off a little bit. It's just the amplitude and the midline. Those happen on the outside of the function, right? So my equation forms a negative sine function, right? And my amplitude is going to be 2. So I just do -2 instead of, 2 times negative sine, which looks a little more funny. And then the midline is going to be -7. So this should be a -7 over here. It looks like my picture got cut off a little bit. I'll see if I can. Oh, I just didn't do it yet. Sorry. So I put in 2, and then I put in the midline. I'm going to move the picture over, and we're going to work on putting the phase shift in. Now, the phase shift and the period go inside the sine function. So we're going to draw out 2 sets of parentheses. The phase shift goes in the innermost one. So since the phase shift is 0, it's really just x plus 0. It could be x minus 0. Those are the same thing. Adding 0 or subtracting 0 doesn't really matter. So we'll just put x plus 0 in there. Now we're going to go to the next, which is just to put in the period. But what we have to realize here is the period is one of, it doesn't go in like in the same way the amplitude, we just automatically put 2 in and we automatically put -7 in. The period, you actually have to put it into the equation, you have to do something to it. And that's always to put it below 2 pi. And this happens in both directions. 2 pi divided by whatever the period is gives you the number that goes into the equation. So even though the period's pi, the number that we put in that indicates what the period's going to be is 2. And that's really tricky for people because they want just pi to go into this equation, right? Like just kind of like -7 just goes into the equation. But it doesn't really work like that. You have to make that subtle adjustment for the period. Okay. And then so after that, all I want to do is just simplify this equation. Like it looks a little weird to write x plus 0. It's kind of redundant, a little bit more than you need. So I just simplify the inside parentheses here and I get 2x. So f of x is equal to -2 sine parentheses 2x minus 7. And that is the final answer. Let me show you. When I put that in, we get the the little ding. So I hope that makes sense, and I'll be doing more examples.